For this particular question, we can answer everything from what is provided in the problem. So we'll start off by reading the question, or the statement. A rocket is shot upward from an initial height of 100 feet, reaches a peak height, and falls back to the ground in 18.1 seconds. The formula that represents the height of the object as a function of the number of seconds t the rocket has been in the air is given by this formula. The maximum height is at, and I will interpret this, 8.9 seconds. You reach a maximum height of 1,522.2 feet. So, first part of the question. The formula is valid only from the time the rocket is first shot upward until the time the rocket returns to the ground. That's a very important statement because it's telling you when the situation actually occurs. Clearly, it would not make sense to use a negative time because the rocket wasn't launched at a negative time. And once the rocket hits the ground, it stops. So I'm going to talk about the relevant graph. So, the initial height of 100 feet means at time 0, the rocket was 100 feet in the air. We know that it reached its peak height at 8.9 seconds, and that peak height was 1,522.2 feet. After it reaches its peak height, it falls back to the ground in 18.1 seconds, which means at exactly 18.1 seconds, the height above the ground is 0 because it is on the ground. So, now that I have properly labeled my graph, I can talk about the relevant graph. The domain is a set of all possible input. In this case, my input is the time. So, need a parenthesis for that point. What times did this occur? Well, it occurred from when it was first launched, time 0, until it went up and it came back and hit the ground 18.1 seconds later. The range is all of the possible outputs. In this case, the outputs are heights. And they are measured with the variable h. So, all of the possible heights, what we need to look at is what is the lowest possible height and what is the highest possible height. So, my three key points have a height of 0, 100, and 1,522.2 feet. The lowest possible height is clearly at exactly 0 feet. The highest it goes is 1,522.2 feet. Okay, next part of the question. It's asking about the domain and range of an abstract function. Well, an abstract formula does not stop. It does not know when the rocket took off, and it does not know when the rocket hit the ground. So what you're really looking at is this parabola, and you know that it goes down forever in this direction, and it goes down forever, not a very good, in this direction. So, in this formula, with x being our input, what x value can you plug in here and use for calculation? Well, according to my graph, from ever to the left, which would be negative infinity, to forever to the right, which would be positive infinity. Now, a parabola's y values are the range, all of the possible y values. So again, we ask the same question, how low does it go? Well, the abstract formula has nothing to do with a rocket. An abstract formula goes forever down. So we know there's no possible minimum, so negative infinity. However, the parabola still has a maximum value at its vertex, and that maximum value, the largest possible y value, is 1,522.2 feet exactly. So that's a bracket there.